The construction of some garments is more complex than others. Yet the construction of a modest t-shirt and an elegant dress shirt both require careful planning to assure they are made according to specifications. As a part of this process, manufacturers must know in advance all components required for manufacture, as well as the order in which construction operations are executed. This section provides some details on those operations for constructing a t-shirt, a pair of jeans, and a dress shirt. The cutting process for t-shirts involves two separate processes: the layup and cutting of the fabric for bodies and sleeves, and the rewinding and bias cutting of fabric strips to be used for necklines and, in some cases, sleeve bands. Companies that produce fabric and also cut and sew the fabric will typically handle the tubular knit fabric in flat folded stacks. The fabric is laid in a zigzag manner during the disposal of the fabric from the last operation in the fabric manufacture sequence. These fan-fold or book-folded stacks may hold as much as 500 pounds, generally a little less than 500 yards of fabric, and will typically be moved on pallets. Depending on the wait time and distance of travel, these stacks may or may not be enclosed in cardboard or other covering. Production facilities that purchase fabric from multiple sources will frequently buy the tubular knit fabric on rolls. The practical limitation for the roll is approximately 80 pounds or yards. Consequently, there is considerable more handling required with rolls, in addition to the expense of the cardboard tubes. A vast majority of commodity t-shirt manufacturers deal with fabric knit to the finished dimensions and spread the fabric as a tube. There are some companies, especially those that have a tapered side seam on their garments, that will slit the fabric down the side and spread the fabric as an open width fabric. We will concentrate on tubular fabric spreading. Spreading machines for tubular knit to size garments will turn the fabric 90 degrees as it is removed from the stack and positioned on the table. This turn will position the crease, which originated along the folded edge of the fabric during finishing, down the center of the spread, which will end up being the side of the garment after cut and sew. Tubular knit spreading machines are typically designed to handle either roll goods or flat fold goods, but not both. Therefore, the introduction of fabric packaged the wrong way will cause major turmoil in a cutting room. The savings of flat fold goods is also negated if the cutting room must unroll many rolls of fabric and stack in a flat manner. This loss is due to the fact that the placement of the end of the fabric through the spreading machine and over the stretching device, threading the machine, is quite time-consuming. The spreader bars on the machine ensure that the edges of the fabric will be nearly even and allow for more precise cutting. With the fabric loaded on the sideboard of the spreader, the operator will move the machine along the table for the predetermined length of the marker. Some spreading machines are manual and must be pushed by the operator, and others have motor drives with which the operator must simply activate the throttle on the machine. Of course, motor drive machines will allow the operator to better watch for defects in the fabric. The length of the spread is determined by a combination of the number of different sizes of shirts and the total number of shirts in the cut. As can be seen in these two examples, the longer spreads are much more efficiently laid on the table, reducing the labor cost. Once the appropriate number of plies are laid up, the marker, comprised of pattern pieces, is positioned on top of the fabric, and cut lines are marked on the fabric by dusting a colored chalk through perforations in the marker material. In the case of body-width t-shirts, the resultant lines will be in the center of the spread for the armholes and curved lines at the top of the body panel for the front and back neckline. The reciprocating blade cutting knife is operated by one of the more highly paid direct labor operators in the plant. An operator in a progressive and safe facility might be wearing protective earplugs or a work glove on the controlling hand, but will definitely be wearing a steel or Kevlar mesh glove on the free hand. The cutter will typically cut the long spread of fabric into segments containing a body and one or more sleeves by cutting the straight edge of one of the pieces across the width of the fabric. The resultant block will be maneuverable and can be moved to the edge of the table for more accurate cutting. The cutter trims the edges of the sleeve and then cuts the curved top, thus removing the sleeve from the lay of fabric. The two curved lines, which will become the front and back necklines, are then cut at the top edges of the body panel. The center line keyhole is then cut, which will become the armholes when the shirt is opened up for sewing. While the body pieces are cut with a manual cutting machine, the trim fabric for the neckline and/or sleeve bands are cut in an entirely different manner. The roll of fabric is fed onto a machine at an angle. A circular knife is used to split the fabric tube and provide an open width piece of fabric. As the fabric is cut, it is wound at the same degree of angle onto a separate roll. This roll is then positioned on a machine equipped with a circular knife similar to a meat slicer or carpenter's saw. The roll of fabric is then sliced into appropriate width strips to be used for trim items on the shirt. The bias winding of the fabric imparts additional stretch to the knit fabric. Care must be taken to match the fabric color of the strips to shirts cut from the same shade of body fabric. The appropriate yardage must be accurately calculated to finish the cut shirts without waste or shortage of trim fabric. Now that cutting is finished, the process continues with assembling the t-shirt. A typical t-shirt is composed of a body panel to which sleeves and a collar are attached. In production, the sleeves are hemmed and sewn into a tube offline. After the shoulders of the body panel are closed, the collar is set and the neck and shoulders are taped. The sleeves are then set into the body. Hemming of the bottom may be done at any point in the process. Lastly, the garment is inspected and any loose threads are trimmed. Now let's take a look at how t-shirts are assembled. This t-shirt is cut from body width goods, and consequently there is no side seam required on the garment. Such construction necessitates that the sleeve be set in the round, meaning that the sleeve has the side seam completed, turning it into a small tube before it is set into the body of the shirt. To improve efficiency, the sleeve is hemmed while it is in a flat configuration, and afterwards the side of the sleeve is closed. The hem on the sleeve is accomplished by feeding the folded edge through a chain stitch machine, normally designated as a cover stitch. An air-assisted folder improves the quality of the sleeves and also lessens the attention required of the operator. A stack of cut sleeves is fed through the folder and collected in a box or bin on the outfeed side of the machine. More automated factories will have an electric eye on the machine to stop the machine when the edge of the fabric reaches the needle. This reduces the amount of thread used and should reduce the amount of thread breakage. Some factories run chain stitch machines even when there is no fabric under the needle, but there is significant thread waste with this procedure. The closed sleeve operator receives sleeves connected in a chain from the hem sleeve operation. The sewing of the two edges of the sleeves is done with another type of chain stitch commonly called an overlock. This machine has a side cutting knife which is designed to remove a small amount of fabric during the formation of the stitch. However, poor operator handling can force the wrong amount of fabric to be cut off, resulting in an improper sleeve measurement. The operator must accurately align the leading edges of the sleeve to assure a first quality garment. It is also imperative that the operator fold the sleeve in the correct direction to consistently have the face side of the fabric on the inside of the resulting tube. Disposal should be in a manner to facilitate transport to the assembly area of the plant. Assembly of the t-shirt begins with the join shoulder operation, which requires two separate sews. Because of the cutting method, the operator must fold back one ply and then crisscross the shoulders in order to match a front and a back shoulder. A plant with efficient methods would use the method shown, in which the shirts remain tied in a bundle during the sewing operation, thus drastically reducing handling. The average plant and/or operator might well handle each shirt individually. This more efficient method requires more skill and attention on the part of the operator. The machine in this operation utilizes a side cutting knife, requiring the operator to carefully align the edges of the shoulder. Special care must be taken to maintain straight edges and square corners because of the bulk of the shirts tied in a bundle. The subsequent operation is set collar band. Collar strips have previously been cut from either rib knit fabric or on the bias from body fabric and sewn into rings of the appropriate length for the size being sewn. The circular strips may be sewn together by the set collar operator or as a parts operation and then stored at the set collar machine, which is an overedge machine raised on the tabletop. The folded strip is placed on roller, set to the correct size, and the shirt is placed over the collar band. Because of the stretchiness of the collar fabric and the handling of 3 plies of fabric, the operator will typically cut off a little additional fabric with the edge trimmer to achieve an even edge of all plies. Allowances should be made in the patterns for this cutoff. A progressive factory may have installed vacuum devices, as seen here, to remove the trimmed fabric and thread from the work area. Again, a well-engineered plant may leave the shirts tied in a bundle for this operation. The increase in difficulty is not as extreme as in joined shoulders. The bundle of shirts is passed to the tape, neck, and shoulder operation. The operator is able to leave the bundle tied up and then pulls the garments onto the sewing head of an off-the-arm 2-needle chain stitch machine. These machines can typically show straight rows of stitching or a zigzag on the bottom, depending on the specifications of the shirt. As can be seen, this specialized machine has the sewing and feed mechanism located in a cylindrical arm located away from the main body of the machine. This machine design allows the seam to be sewn on a garment that is essentially an enclosed tube of fabric after several seams have been sewn. The seam tape is actually a strip of fabric typically cut on the straight grain of the fabric to reduce stretch in the strip. The strip is fed through a folder which turns under the edges before it is stitched over the previous seam. The resulting layer of fabric serves to protect the shoulder seam, keep raw fabric edges from rubbing on the neck of the wearer, and add stability to the shoulder. This machine has a chopping device that trims the thread and the end of the fabric tape at the edge of the shirt. 1 or more labels are inserted at the center back during the sew along the back of the neckline. The hem bottom operation can be done at any time during the sewing process because it is unaffected by the other operations. The bundle is opened at this point and the shirts are handled individually. The machine used is of cylinder bed design, which is raised above the table surface, and the lower workings are in an enclosed case to allow the garment to be sewn in a circular motion. The operator must initially turn the hem under by hand and then gently guide the lower edge of the garment under the foot of the sewing machine. After overlapping the ends of the stitches, the machine trims the sewing threads underneath the garment. The set sleeve operation takes sleeves that had the underseam sewn into a tube in a previous operation and sews them into the hole formed on the side of the garment by the joined shoulder operation. This operation is one of the more difficult tasks because of the 2 circular edges involved. The operation utilizes an overedge machine with a side knife, and the operator must be careful to not change the shape of the armhole or introduce pucker into the seam. Operators in the background can be seen turning the shirts inside out to prepare for the final operations. In this factory, a vacuum system is utilized to draw the sewing waste from the machine. This operator, also setting sleeves, shows the correct way to wear a dust mask, if the operator chooses to wear one. After the sewing operations are completed, the t-shirt must still be inspected, have any remaining threads trimmed and removed, and then be packaged. These work elements can be combined in numerous ways to achieve an acceptable finished product. The operator performing the inspection will frequently turn the garment right side out. Then the garment will be checked for both sewing and fabric defects. Stacks at the inspection station will be used to segregate first quality garments from repairs and irregulars or non-repairable garments. Critical areas will be checked for remaining thread, and then the t-shirt will have the loose threads vacuumed away and some minor pressing done on the areas that tend to pucker. Once the t-shirts are properly cleaned, they will be counted and placed in the appropriate carton. Once the completed cartons are accumulated and scanned, they will be placed in the truck for shipment to either the warehouse or customer staging area.